All right. So I wanted to go into the whole reading the soil test to make recommendations thing. I generally do it before lunch, but you guys are so full of good questions that we didn't get to it. Usually what happens with the questions is you cover stuff that we were going to cover later.
Yep.
So it's not like we're not on schedule. It's just that we're doing things in a little different order. But I am going to focus on this soil testing details right now for a little while. So this is mostly pages 2, 3, and a little bit of 4 that we're going to be covering besides the soil test report form. If you want to get those all out, so you can look at them all at the same time. So the top 2 slides on page 2, slide number 7, slide number 8, those are your target levels from an Albrecht style. Page 2 is its own page. Doesn't have a back to it.
What about 39?
As they're not on here.
Yeah, I didn't see them.
Give me a minute and we'll get to them. When I was printing these out on Thursday, I didn't print out pages 2 and 4 for some reason. I think I pressed the wrong button on the photocopier, so it took pages 1 and 2 and pages 3 and 4 and put 1 and 3 on there and ignored 4 and 2. So 2 and 4 are separate pages and 1 and 3 are front and back. It's not the way it should be. I apologize. All right, so just going through this handout here on top page 2, target levels of macrominerals and target levels of trace elements. These are your targets. This is something I've gotten basically from talking to a number of elders in the field, people who've been doing consulting and stuff for a few decades. When I first started learning about this, and there was no answer in one book. Like, this is the answer. It was, everybody had their own ranges, and so I talked to Jerry Brunetti, I talked to Gary Zimmer, I talked to Arden Anderson, I talked to Bruce Tainio, I talked to Neil Kinsey. I'm not sure if anybody knows all these people's names, but maybe you know a couple of the names. I basically went up to them all and said, what's the deal, guys? Like, how are young people who are just learning about this supposed to figure this out, because you guys are all saying different stuff?
Yep.
And I said, so I went and I asked them all, I said, every single one of you, I said, what's your targets? And then when I got in everybody's targets, I went back to them all and said, now what do you think about, this is what Gary said, but that's what Bruce said, what do you think now? And so we basically weaned it down to a basic target level, which is what I've got here. It's not perfect, it's a ballpark. Don't get too worked up about numbers in general as far as I'm concerned. We have been trained to trust scientists and doctors and lab reports, and I think a little bit too much. So people feel comfortable when they got numbers, they can work towards it, that makes them feel safe. Some people, I just want to say this is a ballpark, this is a target area, this is not like a totally get uptight about it kind of thing. What we're really looking for is which ones are way off and which ones are kind of close. Anybody who's studied agronomy may have heard of this thing called Liebig's barrel. Anybody heard of Liebig's barrel?
Yeah.
Liebig, Justus von Liebig is considered to be the father of conventional ag, soluble nutrients chemistry. Liebig's barrel is, pictured as a old whiskey barrel or wine barrel cut in half. People have sometimes these tomato planters in a barrel kind of a thing. So each of these staves is represented by a mineral. So we got calcium, we got magnesium, we got boron, we got sulfur, we got phosphorus, we got copper, etc. So when you get your soil test back and you see, okay, calcium is at 75% of where it's supposed to be. Magnesium is at 80% of where it's supposed to be. Boron's at 15% of where it's supposed to be. Sulfur is at 10% of where it's supposed to be. Phosphorus is at 50% and copper is at 40%. Liebig's barrel says this is your yield potential. If everything was up at full, then you could actually realize the full yield potential of your crop. Minor side note. I'm sorry, I have too many side notes. Yield potential on corn. Let me know. Yield potential on corn.
175.
That's the yield average.
No, you'll do it.
400.
600,000?
1,000 to 1,200 bushels per acre is the yield potential on field corn, according to the geneticists at Purdue, at Iowa State. The corn geneticists that have done the research,
6 years.
5-6 years per plant, easy. The yield potential, according to the corn geneticists, is 1,000 to 1,200 bushels per acre. Average yield in this country is between 140 and 160, ish. So what percent of yield is that?
Maybe.
Maybe 15 if you want to be generous. Anybody go to school?
If you got 15.
And we got a 15 on a final exam? What do you call that? A big fat F. I took organic chemistry in college, and my final exam was a 35 or 34 or something in that range. And I got a D on my report card because they grade on the curve when everybody fails. And that's where agriculture is right now, is we're all failures. We're all really bad failures. And we're basically like allowed to stay going, but we're barely passing, right?
Yep.
So Liebig's barrel says, okay, sulfur's at 10% of yield, sulfur's at 10% of where it needs to be, therefore your yield will never be 10% of the yield potential, right? That's it. So we look at these things kind of from this perspective. Okay, I know I need 75 parts per million sulfur. I know I've got 7.5 parts per million. That's a priority. Calcium's kind of close to where it needs to be. Magnesium's not too far off. Don't get too worked up about the details. Identify which ones are totally off and start working with those first. Is my general rule of thumb. If there's any violation to that, it's calcium, and calcium is really important. And calcium is generally really cheap. So, as far as I understand, dollars per acre on limestone to address the deficiency is
Do you use limestone?
depending on the pH and depending on the crop that I'm producing. I like to use this thing called carbonatite, which is it's a volcanic mineral. I mean, limestone is basically old seashells, old ocean, diatoms, basically that fell in the ocean, and it's generally relatively poorly available. But at least where I come from, ag lime is like $8 a ton. I'm not sure what it's like down here. I can't believe it would be that much more expensive. 40 some. Spread?
Yeah.
Spread. Well, it's $8 a ton at the quarry.
Oh, yeah, it's only $6 spread. I thought we charged for spread.
Well, there's hauling and stuff.
I'm not sure about the details. In my mind, when I'm making $25,000 an acre, $60 an acre is not a lot of money. But I understand when you're doing pasture, then it's a different conversation. So it's all, everybody's got to take into consideration where they're at. Generally, what people who I have learned from have said is, don't try to do everything everywhere all at once. Start with a couple of acres and do a couple acres well and see if it's true or not, and see what the increase in yield is, and see if actually that investment will turn back money that you can put back into the land. Don't expect you're going to be able to do this, cash flowing it all at once. Put aside some money, put it in, try to do things well. If it's true and if it works, it'll make you more money, which you can then put back into the land, and you can have more confidence and more experience with what you do need to do and what you don't need to do. In general, we're looking for which ones are most totally deficient as the priorities to address. Okay. For people who are working on backyard gardens, I'm guessing there's at least a couple of people in here that are not working on acres but are working on hundreds of square feet or thousands of square feet. I've got this slide called conversions. I'm going to teach you how to read a soil test and make recommendations on pounds per acre. So 500 pounds per acre equals 11.5 pounds per thousand square feet. So you can just basically do some quick, back of the envelope math. Slide number, it's page 2.
I find it much easier to work with.
You're on page 3.
400 pounds per acre is equal to 1 pound or 10 pounds per 100 square feet or 1 pound per 100 square feet.
Because there's
10 pounds per
42,000.
thousand.
Yeah.
Yeah, and you can, 2.5 times 400 is 1,000 pounds per acre. It's a lot easier to work in your head.
Yeah. What he's saying is to ballpark it, so there's 42,000 plus or minus square feet in an acre.
43,000.
43,000.
360.
560, 640,
Five.
ballpark. He was getting rid of the 2,000 or 3,000. He was going straight to 40,000 square feet to do his back of the envelope math, which is 400 pounds per acre equals 10 pounds per thousand
That's
square
what
feet.
Terry Reams taught me.
Because it's all ballparks.
Yeah.
Let's not get too caught up in the details and too anal about, right?
It just makes it easier
Well,
to work
yeah,
in your head.
perfect.
Yeah.
So 400 pounds per acre equals 10 pounds per thousand square feet,
Or 1 pound per 100.
or 1 pound per 100 square feet. Yeah. Anyway, don't want to spend a lot of time on that. Just it's there in the handout for you if you want. Okay. Now, so here's the this is the key piece on how to read a soil test. This is the secret that the agronomists know and you guys don't. Ready? Once you know this, everything else is simple math. Pretty simple. Parts per million times 2 equals pounds per acre. Everybody got that? That's all you need to know to read a soil test and make recommendations. Everything else is simple math.
And that's because they assume it's 6 inches of
Because they
soil
assume
equals
there's
2 million pounds
2
of
million
soil.
pounds of soil in the top 6 inches of an acre, which is the aerobic zone, which is where the biology is pulling the nutrients out from. Exactly. Exactly. So that's what that slide there, number 10, says. So we can pretty much go straight to the soil report and start doing the math here. And we'll figure out pretty quick that once you know how to do one mineral, you can do them all. Because you're just doing some basic math. So I'm not sure if you can read the label here. This is growing area north N/S, which is in the first line. So we'll just run all of our numbers off of this one here. The first element is sulfur. See that?
Yep.
All right. So let's do sulfur. So what's the target level of sulfur?
75.
75 ppm times 2 equals 150 pounds per acre. Yeah? Okay, what does the soil report tell us how much we've got present? We're reading the first one.
16.
16 parts per million times 2 equals 32 pounds per acre. We need 150, we got 32. What do we do? You guys are high tech here. Reading a soil test is really simple. 118 pounds per acre sulfur needed. Complicated? Difficult? Stressful? High math? This is our deficiency. We figured out how much sulfur we need in this acre. This is the easy part. Now we got to figure out what form your sulfur is going to come in. Right? All these elements you're looking for, calcium, potassium, magnesium, phosphorus, boron, copper, zinc, etc. You don't ever find them in their pure form. You don't ever find pure sulfur. You don't find pure calcium. You don't find pure potassium. So what I have written down in the next couple of pages are how much sulfur is in this, how much sulfur is in that, how much potassium is in this. What's that?
Oh, I just, when I first started learning about it, trying to figure out how much was in each product and what I could
Yes.
get and, what was organic. It was like,
Oh my
I had to
God.
have a spreadsheet just to figure out what.
Yes. So I've got a few examples here of things that, and I actually, on this sulfur, for example, slide, you can see slide number 11, I did the math out for you on gypsum, which is a common source of sulfur, calcium sulfate. Anybody who wants to know the background chemistry to figure out, how do you figure out how much sulfur is in gypsum, I did the math out for you here so you can see the atomic weight of calcium is 40, the atomic weight of sulfur is 32, the atomic weight of oxygen is 16, hydrogen is 1. So you add up the atomic weights of CaSO4 plus 2H2O and you get a total atomic weight of 172. And then you figure out what percentage of that is sulfur. You don't need to do this. It's totally unnecessary, but some people are sciencey kind of people. They want to know actually, how do you get these numbers? Why should I trust you? So This is the basic science behind it, is you read the atomic weights. The upshot is 100 pounds of gypsum is 23.5 pounds of calcium and 19 pounds of sulfur, which means that gypsum is 19% sulfur. Yeah? 19 pounds out of 100 pounds means 19%? All right, great. So this is where you have one algebraic equation. If you're a person like me, you do the math in your head, and you round off 19% to 20%, and then you can just sort of divide this by, 5, and you get your answer. Or multiply by 5. But so we have 118 pounds. So this is the one algebraic equation in this whole process. Is you take 118 and you divide it by the percent concentration of sulfur, which in this case is 19. That's the concentration, 19%. So you do 118 divided by 0.19. Anybody got a calculator?
Yeah, 620.
621 pounds per acre gypsum needed.
So what do you do in this situation if you're also relying on
You're wrong.
gypsum as your calcium source,
Yeah.
and it doesn't, that amount doesn't meet?
This is why I'm doing gypsum as an example, because this is something you're going to come up against.
Yeah.
So let's do calcium. So calcium, if you look here on this section right here, they've done the math for you and found we've got a deficit of 112 parts per million. So 112 ppm times 2 equals 224 ppa calcium needed. All right? Gypsum gives us what percent calcium?
23.
So 224 divided by 0.235 equals
About 1,000.
about 1,000. Looks pretty close to 1,000 to me.
Hey, a
1,000
ton.
pounds per acre, and you're getting. We needed how much?
224 came from 112. We have a deficit of 112 parts per million of calcium,
Okay. I
which
see
you
it now.
multiplied times 2 to get pounds per acre
Okay, I'm just trying to use yours and then try to do mine.
at the same time.
Yeah,
Yes.
okay,
So you have to add.
We're going to do this about 4 times.
okay.
By the time you get done with it, you're like, oh,
So with the 621, you don't have enough calcium,
right.
so you have to do 400 pounds or something.
So we have 100 plus or minus 1,000 pounds of gypsum. So we need 621 pounds of gypsum to address the sulfur deficiency. We need 1,000 pounds of gypsum to address the calcium deficiency.
So we have to do 621 and find something.
You
else.
sure aren't going to do, we're going to address deficiencies, we're not going to overdose things,
Right.
right? And there's one last step in here, which is slow and steady wins the race. Anybody ever heard of this? Slow and steady wins the race? My understanding from talking to people who've been doing this for 30 years is just because you need a whole bunch of stuff does not mean putting it all on is a good idea. So you'll see that page 3 of this handout is entirely maximum yearly applications. And the idea here is even if your tank is empty, filling it all up in 1 year is not what is recommended. Slow and steady wins the race. Put a little bit on and come back and check again. And then put a little bit more on and come back and check again. Don't put everything on all at once. If you got a bunch of money and you want to go for it, knock yourself out. What people have generally told me is, in this case, actually sulfur is on the bottom of page 2. So sulfur with calcium needed, 500 pounds per acre gypsum. People see that? Bottom of page 2. So we're going to do 500 pounds of gypsum. That's the answer.
Calcium.
And if we want to do some calcium, we can do limestone.
Would
Gypsum does have
This says a maximum 500 pounds
of gypsum.
of calcium too.
If we need sulfur with calcium,
Ah, okay.
we do gypsum. If you look on the calcium slide, which is over here on top page 3, 500 to 2,000 pounds of limestone. Slow and steady. Basically what's going on is the soil is a digestive system. The soil is a gut. It's bacteria and fungi. And I don't know, what do they say? Thanksgiving dinner? Anybody ever eaten Thanksgiving dinner? Eaten too much? What happens?
Indigestion.
You get groggy. Right? Do you want your soil to get groggy? You want your soil to maintain good levels of energy? You want to, get up from the table with your belly half full?
Takes a lot of energy.
Takes a lot of energy to digest these things, which is one reason why you want to put them down in the fall, and one reason why you want to not put down everything all at once. When it comes to spreading minerals, as far as I'm concerned, the best way to spread minerals is through a digestive system like a compost pile. So anybody who's making compost, if you've got a bedded pack, you guys do bedded packs down here, or you don't do bedded packs because it doesn't get cold enough?
What is it?
Bedded pack. Up in Vermont, say, when it gets down to 40, 50 below zero, and people have cows, they don't keep their cows outside in the winter. They have like a big, pole barn or a big hoop house or something. It's just shelter. It's just one layer of shelter, and they loaf in there. And they basically will come in and they'll put down bedding, whether it's wood chips or hay or whatever, on a regular basis. And you keep doing that every day for 5 months, because that's how long it's cold for. And by the end of the winter time, by the time the grass starts to grow, you got 4.5, 5 feet of, of amazing raw material for a compost pile. So then they go in there with the bobcats or the excavators and pull it all out and pile it up. Or they feed pigs grade on it. There's all kinds of different ways of doing it. That'll compost, and you've got a wonderful. Then you've taken all the manure and all the urine from all the cows, and you can actually put your minerals down in that bedding pack too. So what you do is you say, okay, cows are getting milked. I'm going to go put the new bedding down for them. Before you put the bedding down, you throw a few handfuls of your gypsum and your copper sulfate and your boron, and you put that down in the bedding. You put the next layer of bedding down. They poop on it. When you pull all that stuff out in the spring and pile it up, it composts. And you've taken all your minerals and you've composted them. And so when you spread that compost, you've got a really high test compost, because it's got all these minerals digested and much more bioavailable than they would be if you just spread them on the ground. That's the long and short of it. That's a bedded pack. It seems like the farther south I go, the fewer people do it. I think it's a good idea in general to be capturing all that manure and using it for your farm if you use nitrogen anyways. But people do know about compost and do know about composting. And so anybody who makes compost in general, I would suggest putting your minerals into your compost pile is a good idea. It'll help digest them. I personally don't use compost. What's that?
I think you can put a lot less and get more fresh leach.
Generally, they say you'll get twice as much. The availability will double through composting process. So and I think it probably is more than that. Yeah. Either way, you'd need less to get a similar effect. It depends on your soil. It depends on what's going on. Who was it? The 3.4 pH? Who said they had year 3.4 pH? That's really low.
No matter how much lime I put on, I have never been able to get a soil past 7.
Well, not that you want to go past 7.
I have a hard time getting into 6s.
Yeah.
But these soil tests are in places, I got 3 results back where it's in the mid to low 6s.
That's usually good. Better sign. Your tank is more full.
Right.
Yeah. Anyway, on my farm, I generally broadcast these minerals straight out into the ground. Like I said, I usually keep the soil either green or brown covered. There's not bare soil very often in many places, and I let my dead plant residue fall on the ground and digest. Some people will take your tomato plants out and put them in a compost pile. I let my tomato plants fall into the cover crops. And so I figured to some extent I've got a composting process going on my land, and I'm just saving myself the hassle of carrying things out, turning it, piling it up, hauling it back, and spreading it. Yes, never mind.
The reason they do that is because they're afraid of the disease, right? I mean, if you don't have a host habitat, then, you know, your plants aren't sick, they're not, you know, you can have the disease still there, but they're not gonna get an infection.
Well, I mean, the concept is that you can prevent your plants from getting sick. I'm not sure. There's that argument, and then there's the rotations argument. Anybody ever rotated their crops? Rotated their summer squash from one section to another? Have you found that powdery mildew didn't define your summer squash after you rotated them?
No,
My experience is powdery mildew follows the squash,
goes wherever it is.
and the potato bugs follow the potatoes, and the
That's true.
downy mildew follows the basil and the
This guy has been growing his tomato plants for 18 years in the same tunnel,
yeah,
and he's never had any fungus or disease.
Right.
But he's really into nutrient.
yeah, exactly,
And if I could say one more thing, I took a nutrient management class for NRCS.
yeah.
So I thought it was gonna help me with my farm. But
The implication being it didn't.
it didn't. Well, the one thing they never discussed through this whole week of this class was that you could put too much. You were to go with the report that came out, and if it said you needed 1,000 pounds of lime,
Yeah,
you put 1,000 pounds of lime on it. Whether it, and here it says, this is the most you should put on? That in the discussion never came up.
I'm only getting it from people who've been doing it longer than I have.
Yeah,
And this is something they're pretty clear about.
yeah.
They're like, you know what? Your tank may be really empty, but don't fill it all at once.
Watch out for your extension
Slow and
agent
steady.
comes out and reads your report and says, well, you have to put 2,000 pounds of this on.
People are told to put 2 or 3 tons of lime down per acre, and it shuts the system down.
Yeah,
You put down all that lime all at once, and it'll give your soil indigestion, and everything goes.
yeah. I
And-
think I've done that.
Yeah, a couple tons of lime will do it. A couple tons of lime will do it. If you don't, especially if you don't have good biological activity, it'll absolutely do it. Absolutely. So, anyway, interesting. So, you've got the basic math here. I want to just run through like 4 different elements. I'll do one more on the board, and then you can practice doing one, and then we'll see how much longer you need to keep doing this. It's really simple. The math is really simple. I'll erase this. Once you figure it out, you're like, oh, I got this. For those who want supplemental reading, there is a really good book called The Ideal Soil by Michael Estera, I believe, which is like an 85-page handbook, The Ideal Soil, which walks you through how to do this. It's all written down. It's got paragraphs. It's got explanations. Michael Estera, A-S-T-E-R-A. I believe you can get it on soilminerals.com. Soilminerals.com, which is actually one of the 2 or 3 websites where you can actually upload your soil report data, and they'll spit out recommendations for you. The only problem with these sites is that they will not have this max application rate per year. They will give you everything because they're then selling you also the minerals. So one always must question the incentive behind people's
What do you think
actions.
of the book, The Intelligent Gardener?
Also good. It's much more comprehensive. It's one of the better sort of comprehensive books out there, I think. The Intelligent Gardener, recently published like 2 or 3 years ago. Steve Solomon, The Intelligent Gardener, and he's got a website also where you can upload your soil report readings, and he'll spit out recommendations for you and sell you minerals. Yes. I like people to have the idea that they can do it themselves and not need to trust somebody else. I just, on principle, think that's a good idea. But most people want to ask somebody else to do it for them. So, anyway, let's do boron on here. Okay? So, I will write on the board while you guys tell me what to do. What's the first step? Boron.
Report on Parker, Parker,
Usually something that goes above that.
0.38 times 38 ppm times 2.
pound is 3 ppm.
All right. Now 0.38.
Do that times 2 to give you your pounds.
All set?
And then you do a point. These pounds. Yeah. 0.70.
Subtract.
And 5 point.
Is it 2.4?
5.24 pounds per acre. of boron. Doesn't take very much.
All right. Nothing too sophisticated here. I think you might need to look at the top of page 4 to find.
Maximum application.
Now, first, you got to figure out what you're going to use. Borax is the common borax soap that one might find in a grocery store. Generally, people with backyard gardens will use that. Solubor or boric acid is generally used by farmers. We get it in 50-pound bags. And generally ends up being less expensive. It's harder to find, but it's less expensive.
Here it is right here.
So what do you guys want to use? Solubor? Borax. The votes are very close here. Solubor, we got 2 more votes for Solubor. Okay, so we're using Solubor. All right, what do we do? Divide. Solubor. We had a majority of votes for Solubor. So we do 5.24 divided by 0.2. Yes? Everybody's following? No.
No, 0.2.
So Solubor is 20% boron. It's on the top of page 4. Where is page 4? Right there. It's all in there somewhere. You can make notes to yourself if you want. Okay, everybody figured it out now? Boron is 20% boron in Solubor, so 5.24 divided by 0.2 equals 26.2 pounds per acre Solubor. Is that the answer?
No, because the max you can do is 15.
That's not the answer because that's the max. The max is lower than that. So the answer is 15 pounds per acre. I'll write this. I'll write it in PPA.
How frequently should you take a soil sample?
Great. I generally recommend an annual soil test. I generally recommend the fall equinox. Bottom of page 3.
So I didn't hear what you just said. I was looking for boron.
If you circle the slides that have critical things on them and make arrows, it's sometimes easier to find them later. The question was, when do you take soil tests or how often? I generally recommend an annual soil test for the first couple of years. I generally suggest the fall equinox is a good time to take a soil test. You don't want to be putting down 15 pounds of Solubor over your vegetables. You may easily burn things. So generally, when your cover crops are established at the end of the growing season is when I want to be putting down things like this. Trace elements in general are unnatural materials. Borax is not. Solubor is. Copper sulfate is unnatural. Manganese sulfate is unnatural. Zinc sulfate is unnatural. What's that?
The sulfates are also fungicides, so you go too high, you kill your good fungus. You can hurt.
So there's a couple things about how you apply them. Just for starters, everything here is approved for certified organic farms.